Surrounded by snaps everywhere.
Thank you. Thank you. So I'm Kevin Ottens. I've been around the community for 20 years or so, and I'm working for enioka Haute Couture. As part of my involvement with enioka and Haute Couture, we ended up working with Canonical on what we are calling KDE Neon Core, and that's what this is about. So you might have heard about Ubuntu Core. The definition they give is basically Ubuntu Core is a minimal, secure, and strictly confined operating system. It's been designed for embedded systems. Initially, it's basically the immutable version of Ubuntu, just like the equivalents on the Red Hat side, OpenSUSE side, and so on. Supposed to be secure by design. Everything is containerized in there. And all the components are in snaps. Interestingly, on that one, though, even the kernel or the snapd, which is what orchestrated the snaps, they're also inside of snaps, right? So everything is containerized. That makes it easier for the over-the-air updates, and there's an automated rollback system if needed. Then I came up with the idea of let's extend that and go toward Ubuntu Core Desktop. So the idea is to have a fully containerized desktop this time, where each component is immutable and isolated. So it's been announced last year, and they made a full desktop session on top of Ubuntu Core. The idea is to have the same benefits that Ubuntu Core itself, but for user-facing GUIs, to make it harder for malicious software to get there or to spread, to have not have updates which leave you in an unstable state, to make it all easier to audit, verify, and also to avoid having inconsistencies from system to system. They are supposed to be all identical as long as they have the same components. That comes with extra challenge in that particular space, though, because the constraints are not exactly the same than for embedded systems. It's actually harder to draw the boundaries because all desktops are kind of big block, right? So it's harder to draw the boundaries to actually containerize properly everything. And also with the rollback system and everything, since the desktops are big, we're generally using way more storage than for an embedded system. Next to that, there's been this idea floating around of KDE Neon Core. And the idea, in a nutshell, that's all the KDE Neon benefits, but on top of Ubuntu Core, we changed the base instead of a traditional Ubuntu. We're following a similar architecture to the Ubuntu Core Desktop, except that this time that's a Plasma-based user experience. And we're trying to provide the greatest and latest of KDE software. It also provides, in that effort, we're also trying to build up and provide building blocks to make it easier to snap the KDE applications, even for use outside of Ubuntu Core. All right, this will be kind of a technical talk, so I will get back a bit more into the basics of the confinement of snap, starting with how do you make a snap? That requires a build recipe, so that there's snapcraft.yaml. And then you have a tool, Snapcraft, builds the package, end of story, basically, right? You still have to publish and so on. But in the recipe, you find metadata to declare your application, the targeted base system, because you build on you expect some particular runtime to be able to run what you're building. And you declare all the apps which are provided by the package. You can have more than one app inside of a package, and that's valid. You also declare the interfaces which are used for all of those, so which can be on the plug side or the solid side, depending if you're consuming or providing. And then there's the actual build recipe. So you declare which packages you need to be able to build. You declare how to actually build each of the parts which are in your snap. So that's this kind of YAML. So I'm too small, I cannot jump to point. So that's basically the metadata, right? And the base system that you're targeting. And then we see the plugs here, we see some slots here. Okay, so this kind of very simple declaration I'm talking about. And in the case of KDE apps, we have this one, which is important for us. That's one of the things which makes it easier for KDE apps, because lots of our apps have similar expectations of what they need. So that's factored in what they call an extension, so that the KDE Neon 6 extension, which pre-wires some of what's needed. What's pre-wired? That's mainly some environment variables. So we position the path properly, the XDG underscore yada yada are positioned and so on. We also declare the build time, runtime dependencies on KDE frameworks and Qt, and some common plugs. We're providing a desktop application, so we need to be able to connect to the actual desktop. We're using OpenGL, so we need that and so on. So a few of those. Once you have a package, how does it work actually when you run it? That's two steps when you run a snap. When an application is launched, there's first snap confine, which is executed, and this one we set up the environment, the execution environment. Sorry. This one will position environment variables like the home day of the user, some snap specific variables, and so on. Then it will start to do funky stuff like providing a private namespace for mount points, providing a private TMP, so you have no way to actually see what's going on with the other ones. And then it will start setting up seccomp filters, AppArmor profiles to restrict what the application can do, and the kernel, which basically arbiters all of that. Once it did that, there's the actual execution environment you want for your app. And then it passes to snapexec. Snapexec, what it does is looking in the metadata file, which has been generated with the snap, find out what is the actual command for the application, and just run that. But at that point, you're inside of the confined environment. Applications on Snapcraft, they can also be declared as daemons. If you do that, you also get extra files next to that, which are generated, which are basically systemd service files. Except that those ones don't run the command directly, they go through Snap to run the command. At that point, one has to wonder where the filters for seccomp and the profiles for AppArmor coming from. That's snapd, which basically manages this. When you uninstall some things, it will create or remove the profiles. And then when you disconnect some of the interfaces, it will update said profiles following some rules, which means that somewhere in snapd, that will be important later, there is code which basically maps from those nice desktop and OpenGL names that I showed before to actual templates. All right, the architecture for KDE Neon Core is the following currently. So everything which is blue, that's components that we've been working on for that project. Everything which is orange, that's stuff that we've been reusing as is, and which is on regular Ubuntu Core or Ubuntu Core Desktop. There are several things here. So the easiest thing to spot that's at the top, the applications we've been working on. So there's a few more, but we've been working on a few applications. All of those, they depend on what they call a content snap, which is the one providing the Qt and KDE frameworks runtime. Okay, so all of those, they basically see the files from that content snap to just be able to run. But they're running inside of a session, okay? And so they need to talk to something which provide the right interfaces. So I mentioned the desktop interface earlier. This desktop interface is provided by your Plasma desktop session snap, which interestingly, the way it's done currently in the architecture is 16 kilobytes or so, something very, very small, because that's just a tiny bunch of scripts which all point to what we have under here, which is the base snap. And that's where in the base snap currently, we're basically putting all the binaries which are making your usual KDE session. There's some technicality with this, which forces us to, I won't get into the details here because I won't have the time, but that forces us to have a third snap. Otherwise, we cannot make a system which boots with that particular base snap, but I'm not getting the details there. One thing to spot here is that currently what we're doing is that the Plasma Core 22 desktop, as I said, has all the binaries. Right now, we're populating this with the Debian packages coming from KDE Neon. Okay, so the actual session is coming from that. What in the runtime and the applications at the top, that's actually a rebuild for each application and each content snap. So those are from the sources. Once you have that, you can get to system that you want to boot. So we're providing SDDM inside of the base snap. And then you need to do, you boot and you have no user yet, right? So you need to do the first boot provisioning. SDDM is ran outside of the confinement, which is easier in that case because then we can do pretty much whatever we want. And so on first boot, we check if there's a regular user which exists. If that's the case, if that's not the case, we sneakily override the SDDM config so that it auto logins as root directly with a very minimal session, spawns the so the wizard that we see, the orange block there, spawn that wizard, get your information, create the user, restart SDDM, and then at that point you have a regular login process. Interestingly, we had to do that work manually. I found out during that project that GDM actually has that by default. That's a feature which is provided, but we had to kind of build it. Once you're there, you can get in. You can boot Plasma. So one of the things is actually starting it. And currently, or by default, we are driving everything with systemd for the boot. So here in red, I'm showing all the parts, right, all the services which are talking to systemd. The green ones, that's basically a single line of calling to QDBus, but they are not doing much otherwise. They are just one shot and they don't stay. And the orange ones, that the ones not talking to systemd but staying around a bit longer. So the first one to kickstart that is start Plasma, which is not really a systemd service, but it talks to systemd to say, okay, set up that target so that we can have a proper desktop. It also says things like, here is the environment I want you to give to every services which are started. Okay, so we are doing those calls to systemd for start Plasma, and then that will kickstart the rest. Queen Wayland similarly will force some of the environment because you need to know where is the Wayland socket, for instance, this kind of stuff. And that's pretty much it. And through the dependencies, we have the order of what will be started. That's a very simplified, idealistic version of the thing, but that's roughly how it goes. So that gets us to an unconfined startup, because first you want to try your things without the confinement really activated, right? You put everything in the snap and you try to boot that, saying, yeah, don't put the filters, the apparent profile yet. That will be fine. I'm just testing things, right? That's not what you want in production, but as a developer, that actually helps. And so that should be super easy, right? We just declared the necessary to start Plasma exposed so that it could be started, to have the necessary to have the desktop portal implementation for us. We boot and we get a black screen. Not exactly what we expected. Looking into it, turned out to be a nice deadlock between Queen Wayland and the XDG desktop portal KDE implementation. And as Queen Wayland is stuck, well, nothing can proceed, nothing can display, and that's why you have a black screen. So why that deadlock in the first place? You remember that snap confines position some environment variables, right? And there's one which is the snap environment variable. Turns out that if it's positioned, QGUI applications feels entitled to do stuff behind your back. One of those things is to say, well, you seem to be running confined, so I will force a particular platform theme, which will talk to the desktop portal. So we end up with a very nice dependency at runtime, which is Queen Wayland loads that platform theme, which tries to talk to XDG desktop portal, which tries to talk to Queen Wayland. Similarly, we have the XDG desktop portal KDE implementation, which loads the portal platform theme from Qt and tries to talk to itself. That can go well, right? This variable was in fact inherited by start Plasma. You remember I said that start Plasma pushes some environment. The implementation we have by default is basically, it does something like, that's all of my environment. I put everything there. Which didn't quite work as we wanted in that particular case. So it does that through the update activation environment call. So there are several ways to reduce the issue. So one is to say, well, I control what's in the base snap, right? So I could just shoot the platform theme plugin and then Qt is not able to load it anymore. That kind of worked, but that's not perfect because in fact, QGUI application changed its behavior in some other ways, which were not ideal. So what we are running with right now, the second solution, where we have a one-shot systemd service, which basically comes just before Queen Wayland, clean up the environment, and then lets everything proceed, right? The real fix, which got merged a couple of weeks ago, but we're waiting on the packaging to catch up, is to modify start plasma to actually be a bit smarter and say, oh, that's actually stuff for the confinement that doesn't make sense for me to push it up. So we finally got something working, but that's not confined yet. So now we want to confine it, and then things break badly again, and that's mainly because we are talking to systemd directly, and by default, you're not supposed to talk to systemd because snapd, to do its job, actually use some of the systemd facilities and so on. So obviously, it tries to be between you and systemd. It doesn't really want you to talk to it directly. In particular, there's no interface in stock snapd, which allows you to use start unit or update activation environment, which are mainly the two things that start plasma would be calling. So when you're like this, that's security, right? You take the power drill and then you start making holes so that it starts working. That's pretty much what this is about. So we submitted a new interface, which we call systemd user control. And this one allows whoever has that interface as a plug to be able to call start unit and update activation environment. Clearly, this is risky, right? Because then you start talking to systemd directly. As I said, that's not necessarily something you want to do. That's a good way for you to manage to actually start something unconfined. But Snap packages using this are actually like there's very few of them, right? There would be the GNOME session because at some point they will have the same problems of using the systemd, driving with systemd. So they just need to be scrutinized, say, right? But the patch is still in discussion exactly for this, right? Because it has security implications, so it's going through a very lengthy process of actually being merged due to this. Now, there's a note about KIO, is that we figured that during the startup, we also hit KIO K-process runner. And that one has the good idea of not calling start unit, but to call start transient unit, which is a good way to basically execute anything you want, even if that doesn't have a pre-created service file on the disk. So security-wise, this is even more frowned upon than start unit itself, because that opens the door to randomly executing whatever code that whoever wants to execute there. Luckily, yes, I know. Luckily, there are still the KDE applications as forking environment variable. That does the trick for now. That's probably not what I would recommend to the community long term, but for short to mid term, I think that's what we want to maintain. And this way, this forces KIO to go through the old fork-based code path, and that does the trick currently. All right, so with that, we can start to confine the session. So we put a new plugin in place. Not everything was working properly. We had some issues with Ksplash and so on. Long story short, we basically adjusted some more interfaces, and that's to be expected, right? Because they did most of the work on GNOME. We're using similar interfaces, but with slightly different way of doing it. So we find issues, things that they didn't think about when they were putting in place the interfaces. Also via QDBus, we tend to introspect a bit more aggressively, and generally the introspection is not in the profiles, but that's things which are trivial to add, and they are not too scared about that. Oh, clicky. So we improved a bunch of interfaces due to this. We also declared all the debug services, because you have to do that with Snap. All the names for the services that you will bind to, you have to declare them all in your Snapcraft. So you did all of that. And with that, we finally got something which was working from startup to shutdown. We're happy. Everything goes well. We have other tasks, right? Because there's more to that project. And we work on that. But something is not feeling quite right. And with the comments we get on some of the adjustments on the interfaces, at some point we figure that there's something which is really not good. So that's our wake-up call. So we get back to it. We use systemd cgls to actually check how the things are confined, in which slice there are, and so on. And then we figured out, we nicely confined start plasma. But then start plasma actually started everything as regular services, right? That's exactly the trap which I mentioned earlier, right? So most of the stuff was bypassing snapd still. So we went back to the drawing board, added a bunch of aliases on the services so that we don't provide the regular service files from KDE, but the ones generated by snapd because of the daemons we declared. And then at that point, it actually all goes through snap. So we get everything confined, a bit more adjustments we find at that point. And finally, back on track, we have something which is fully confined. We have all the services which are confined, including Queen, Plasma Shell, KDE D6, and they all have their own rules for what they can and cannot do, and that can be completely differentiated. Now, if you get there, you have Plasma Shell or KRunner, and you want to start apps, right? But the whole point of confining everything that you cannot call other apps, right? So if you cannot start apps from Plasma Shell or KRunner, that's kind of pointless. So how do we even start the other apps from there? That's actually a snapd feature which is pending, that the people who did the GNOME side of things, they depend on it as well. So we just reuse that, where snapd generates an extra desktop file for the application, which is declared. In that case, that one which is generated as a specific exec line, so that's not your regular exec line, which goes through something that they call snap routine desktop launch, which would then call into dbus interface. A dbus interface which is exposed by snapd, and then snapd will start the actual application for you. You have access to that dbus interface only if you have the desktop launch plug, which we declare just for Plasma Shell and KRunner. Fun fact, when you start using that one, it horribly breaks if you have the snap variable which is positioned. So if you have that and you try to boot the session and you don't do the dance of cleanup I mentioned earlier, doesn't boot, you get a black screen, but you have to like your black screens at that point. So that's for the session. We've also been working on a few actual applications. So for the applications, it looks like this. We have two SDKs, one for Qt, one for Qt plus frameworks, basically. And then from this one, we derive the KF6 Core 22, which is a content snap for the runtime, okay? So at build time, if you're making your own application snap, at build time, you declare that you need the SDK, and then at runtime that you need the content snap for the runtime, which is exactly what the Neon extension does. I won't get into the details, but obviously theming is like a bit of trouble. There have some systems in snapd to try to offset that a bit. But the fact that we provide QSty as binaries, for instance, is kind of problematic. That's something which will need to be revisited at some point. For the applications, as part of the project, we're covering only a few. That's you have like the main use cases you might need for an application, like seeing images, documents, editing something, saving. And we also have some sound, videos, and Discover to actually, because it's a bit peculiar there, because it needs to, it interacts with snapd itself in a way. So we covered of that. Those become then good blueprints for other applications to be snapped, right? Because that gives enough cases to inspire other people to snap more applications. The good news that in our experience, most of them worked out of the box without any particular work. Once you declare exactly what it does, right, inside of the YAML, then pretty much work. The only exception to that has been discovered. We had to patch it a bit because obviously it has a strong proximity with Snapd, so more things could go wrong. For instance, was assuming that the packages were auto-updated all the time, which can be disabled. So we modified that so that the assumption was not there anymore. And it was also going through Snap Run to launch the applications which were installed, which as soon as you put Discover itself in a Snap, you cannot do anymore. For the apps, we want to have automated tests because we want the snaps to to have functional tests run on them before we even push to the Snap Store. And so we are trying to have Appium tests for that. So far, not everything that we have snapped is actually covered. We are covering Cave-Write, Ocular, and Gwenview. This uncovered a couple of issues with the AT-SPY driver. And so we submitted a couple of simple patches. So problem of interface in the API, and also the API tests are, you declare the application you want to start, but we don't want to change the code of the test suite just because it's going through a snap instead of picking the one which is on your system. So we needed to adjust to make that a bit easier. One thing which is blocking to get more of those, that we are still seeing some flakiness from those tests on the CI, and that still needs to be investigated. Talking about CI, we are doing everything to build and publish the snaps. Obviously, naively, we expected that it would be there when we started the project. Turned out that someone, I won't name, pulled the plugs out of what was existing before that. So we had to build something new. Snapcraft proved to be difficult to run inside of rootless containers, which is exactly what we use on our CI, of course. So we had to move everything for now on a VM, which is provided by the KDE sysadmins, and thanks for that. We have the SSH access here. The idea is that it should turn into, hopefully that will turn into a good blueprint, which can be reused after that for the sysadmins for ephemeral VMs, at least for our use case. We managed to properly build the snaps, push them all the way to the store. For now, we went simple, just pushes everything to latest edge because you can have several channels for all the applications. We plan to support that a bit later. And once the flakiness issues with the AT-SPY WebDriver are solved, we will actually block that the tests don't pass. That's not all we need to build, right? Because the snaps, so the building blocks, but we want to build the overall system. So we need to build images. For that, we use Ubuntu Image, which makes you a system image. And that was, say, not easy to set up on the CI. The input files that they use need to be signed. And so we try to have the developers managing their keys locally and so on, but that's just annoying for everyone. And then we found out that later on we would need to do things where it actually needs to be signed with the actual KDE keys. So we had to walk away from this. And so we couldn't rely on Ben as a service to sign the models for us every time we change them. So what we have now is that we have a manual CI job where we say, okay, I'm changing the model files, please sign and generate for me. I still have to download them and so on, but we are fine. This makes it much easier. And then we also have to build ISOs, right? Because images, full images, that's nice if you want to spawn with QEMU. But then if you want to install into like something which is a real machine or so, you prefer, that's better to have an ISO. So for that, again, rootless containers, they don't really like this because you need to do, there are a lot of steps involved where you need to do some root level things, at least as we needed to move quickly. There's, especially with the tools we're using, we need to do bind mounts, and that was a problem. And so obviously we cannot wait to have like the ephemeral VMs on the CI. All right, so for the challenges, as you can see, we encountered several problems on that project. So black screens of various provenance, with and without the confinements, applications which don't start. I glanced a bit over that, but that happened. Applications which are not doing what they should, and by not doing what they should, that goes from glitches to word behaviors and so on. So how did we approach those? If you got problem with a Snap application, it's probably worth checking first if, well, can you get that outside of Ubuntu Core as well, right? When you use the Snap like on your host. And if you still see the problem, then that's probably something with your application and the Snap. So you have to troubleshoot. You can use, there's some tooling there. So Snappy Debug helps quite a bit. It even suggests fixes when you have problems with the SEP component AppArmor. Then you can introspect with Snap Run Shell the actual environment which is seen without starting the app. So you can be inside of the confinement and see how your application will see the system. You can trace into something. You can have GDB server, and then, well, you need debug info-d clearly. So that's nice. I mean, there's some tooling, right? Now, if you have problem with the session, well, you can still use Snappy Debug. The only problem is that the proposed fixes are generally a lie. And that makes sense, right? It's been written from the perspective of making an application, not a session. So very often it gives you the opposite solution that you would need, right? Because you're not sitting on the same side of the fence. Apart from that, you're a bit on your own. There won't be any specific tooling which will help, so you have to go lower levels. You can roll your own Plasma Desktop Session Snap, the one I mentioned earlier. That's just a bunch of scripts, so you could always add some more environment variables, clever things inside of the script, install that, reboot the session, and then you get more logs, basically. You can also roll out your own Plasma Core Desktop Snap if things go really, really bad and you cannot even log in the system or get to any logs or anything like this. So we're providing a small script to make that easier, which enable a bunch of things, like, for instance, having a password-less root access on the serial port. That's clearly just for the developers locally to use. All of this is immutable, and you need to keep that in mind at every step. That means you have to be strategic in what you prioritize when you introspect, because there are things you can iterate quickly on, like the applications, like the session snap, or even snapd itself that you can actually reinstall. At best, you restart the session with the session snap. That from time to time, you might need a reboot with snapd, but not very often in my experience. But if you need to touch the base snap, well, then it takes a while, right? And you can go get a coffee and everything. This is a much slower feedback loop, so it's better to not do that often. There are current limitations with what we are doing, mainly because of the unmerged interface, which is still in discussion. Because it's unmerged, so the official snapd doesn't have it. So we have to ship like snapd, which has that on top. That's fine. We managed to get that in the store. We are collaborating with Canonical for that. That also means that you cannot have an assertion on the Snap store which says, yeah, I allow you to have that interface. So you cannot really publish on the store, which makes it very interesting for people to actually get it when they build their image. So even on the CI right now, we're injecting like a local build of what we did straight in the image, and that's far from ideal. And that's not the end of it, because then at runtime, nothing will auto-connect to Plasma Desktop Session because of that. So you need to connect manually. This isn't great. We hope that's getting slowly resolved, and we hope that soon we will have a nicer experience due to this. There's some upcoming work. So one is currently, as you've seen, that was Core 22 everywhere. We have to do the switch to Core 24. And so we were a bit waiting for a snapshot of numbat for KDE Neon for that. So we have this, so we should be able to start soon. That shouldn't impact our architecture much, but then that means that plenty of stuff will change at the same time, and we expect a lot could go wrong. By doing this, we will also have a better approach for the provisioning, because on Core 24, they provide some services for that, so hopefully we will do better than what we're doing now. Now, the big one is that even on the GNOME side, they're moving to a more modular architecture, because The fact that we are stuffing everything in the base snap, that's kind of a problem for composability, right? That's kind of a problem for reuse of what the fixes that they do on Core 24. So there will be an effort to actually split things up a bit further. Not everything is settled in stone, but the idea is that we will probably have like a content snap, so everything will be in different prefix, and then the session snap and this DDM referring to this. Where we are not sure yet is that do we want the Plasma core content snap to actually reuse the runtime bits of KDE frameworks, or do we want a separate one? That's something we still have to figure out. A few lessons learned. I never really liked packaging, I confess. But I have to admit that for Snap, the Snapcraft rules are not too bad. The extension that we introduced actually helps quite a bit. That wasn't too horrible. The Ubuntu Core Desktop architecture is still a bit in a state of flux, right? So that means things are less documented, the tools have sharper edges, and well, we basically jump ourselves on every knife we find. And the behavior enforced by the Snap Store that actually makes things slower for the development. For instance, the interface, which is on hold currently. We have good tooling nowadays to debug systemd issues, and we're happy about that. You have to double check, triple check when you confine, but if you screw it up and you didn't confine, that's fine, because really you don't want to confine much and then you want to confine more over time, which in the end is what we did. And we should definitely start to think about ways of avoiding start transient unit, or provide fork-based alternative or service like GVFS or something like this. We can't afford to completely deprecate and not provide anything if we want to be serious about the sandboxing. To contribute, that's all on Invent. So there's the Ubuntu Core package project, the Snap packaging group, there's plenty there. We have some guidelines, how-tos, and there's KDE Neon Core page, so you can come talk to me. I'm just taking the time left to thank the team at enioka Haute Couture, which helped with that, and also the contractors we've been working with. So Scarlett Moore, who is unfortunately not here this year, and Carlos the Main, who is probably somewhere around here. And I'd like also to thank some of the people who provided help on their spare time and bounced ideas, like Harald and David Edmondson, or Ben, which I annoyed a lot with the CI. Thanks for your attention. I'm not sure we have time for questions, but
you have 60 seconds for questions.
Okay, that's called one question then. All right, thank you.